So let's begin with this thing here. Reminder, last time when we began chapter 5.1, we began with the probability distribution, which is 5.1. Today in 5.2, our goal for us is to finish 5.2 today. If not, we'll finish it tomorrow. But 5.2, we will deal with a binomial distribution. So 5.1 is pretty much you have a probability distribution, you have some discrete data, and each of that data have a different probability. They distribute evenly in term, not evenly, but in terms that the total probability can distribute to your data. Now, this is the criteria or a condition to met for a binomial distribution. So the two things that we need to have is, again, in order to be a binomial distribution, we need to have a fixed number of trial, meaning we need to conduct something in terms of a fixed number of time. And in each trial, in each item that you conduct, you have only two outcomes, which is either a success or a failure, right? Meaning if you flip the coin, those are your binomial distribution in terms of binomial probability, in terms that you either have a head or a tail, which is you have only two outcomes, okay? And again, the probability of each trial should be the same, meaning again, if you flip the coin, the first time is the same as the second time, it's the same as the third time, meaning every time you flip the coin, you have 50-50 of head or tail, right? And then each trial, each time you flip the coin does not affect one another in the sense of that. So in the idea of this thing here, this four item have to be met in order to be considered as a binomial distribution. Okay, and then the last item, which is the X, will be represent the number of success that we want to have in our trial. Okay, and as you will see later, the most important thing in binomial distribution, or when we try to find the binomial probability distribution, is this three item is we need to know the N, which is the total number of fixed trial, the total number of item, or later on you see that the number of people, the probability of success, which is P, small lowercase p, which is the probability of a success, meaning again, it can be 50-50, 25%, or something in whatever the probability rate that they give us. And then we need to know the X, which is among the total, how many items should we or can we choose? Okay, so again, that's the idea of this item here. But let's take a look at the first example here in terms of how can we determine if this item, if I give you this item, how can we determine if this qualify as a binomial distribution or not qualify as a normal distribution? Okay, so if you look at number one and number two, very identically, right? Number one, they say a coin, which is again, we have a coin, a head or a tail. We toss this coin up in the air 7 times. Let X be the number of head we obtain, right? We flip the coin up, flip the coin 7 times, and now X is a number of the coin land on the head. So is this a binomial distribution table, or not table, but is this a binomial distribution? As you can see, it is a binomial distribution, which is how many trials should we do, which is we know that the N here is equal to 7, right? We have a fixed number of trial, which is we flip the coin 7 times. So what is the difference between number one versus number two? Well, number two, do we have a fixed number of trial? This thing here just basically unlimitedly, we just flip the coin until we see a head appear, right? Which is looking at this thing here, this is not a binomial distribution table because it does not have a fixed number of trial, right? We need to have a fixed number of trial in order for us to consider a binomial distribution, okay? So this one here, because it can be different, right? I can flip the first time and land on head, I'm done. Right? I can flip 10 times and I don't have any head. I still flip the 11 time, right? So I don't have a fixed number of trial. So that's why it cannot consider to be a binomial distribution. Okay. Number 3 and 4 is a little bit different. This thing here is kind of, they bend the rule a little bit to make it a binomial distribution table or a binomial distribute distribution, right? So looking at this thing here, 10 students are chosen from a statistic class of 25 students. Let X be the people or the person who have an A in the class. So looking at this thing here, a little bit different in terms of 3 and 4 is we take some sample from a population. So one thing is you guys will say, well, this thing will not be a binomial distribution because each student are different from among each other, right? Because remember on previously, they say that every trial should have the same probability, right? Flipping the coin should have, every time you flip the coin should have the same probability each time. But this one here, 10 individual students, you would say, well, you know, it's not really independent in terms that each of them, you know, if you take one, you have one less, or something in that nature is dependent. But one thing is we bend this rule right here in terms that we have a small rule that if we take some number of people from the population, this is a small rule to consider as a binomial distribution is if you take a number of sample less than 5%. If you take the number of sample less than 5%, then we will consider this as an independent item. Okay. So again, looking at this thing here, if you remember last time in chapter 4, when we talk about a unusual event, the unusual event, the cutoff is 5% or 0.05, right? So pretty much this thing here, they tell you if we deal with some number of student or some number of population, if the number that we take out is less than 5%, less than 0.05, then we will consider this a binomial distribution. Okay. So again, you know, some of you guys say, well, Mr. Tran, the grade is not only 2 outcomes. Well, they twist it and make it 2 outcomes. I know there are some A student, there are some B student, there are C student, there are D, and then F student in a grade and scale. But again, this thing here, they twist it in terms that you either have an A or you don't have an A. And they make it a binomial distribution in terms of that's only 2 outcomes. You either have an A or not an A. But again, this thing here, 3 and 4 does not follow this criteria. Does not follow this criteria because this criteria is when you perform some item in terms of a fixed number of items. 3 and 4, we are sampling something. We take some people or some item from a group of something. So when we deal with this data, we have to basically tell us that if the sample that we take out is less than 5% of the population, then it's appear or is assumed to be a binomial distribution. Okay, so those are the only 2 different criteria that you need to look at to verify if they are a binomial distribution. Okay. One thing is in 5.2, our main goal is not to identify if it's a binomial distribution or not. Most of the time they will tell you that it's a binomial distribution. Your goal in 5.2 is now how do we calculate the probability of this item here. So there are 3 methods to calculate the probability of a binomial distribution. So the first method is we're using the formula, which is this is your formula for the probability of X. Remember, X is the number of items that we want, the number of success items that we want, right? So the probability of X is equal to NCX, which is, again, this is a combination of the total and from the item that we're using is just that instead of all, we use an X, multiply a P of X, multiply to 1 minus P raised to the N minus X. Okay, so basically this is one thing I tell you guys, ladies and gentlemen, this is the most important thing in 5.2 is in order for you to compute, in order for you to find the probability of something, this is what you need is the 3 items that you need is you need the N, you need the P, and you need the X. The N will be the total of people or the total of trial or the total of question that we have. The P is the probability of you have that question correct or the probability of you get that people, pretty much the success rate that they give us. And the X is the number of items we want it to be. Okay, so just imagine, you know, like this, or the next problem we see. But so let's take a look at this thing here, which is, this is your typical test question, or this is your typical problem, right? This is what they tell you is, for instance, let's say that you come to class tomorrow, right? And in the beginning of class, I give you a pop test or pop quiz, right, on chapter 6. And again, pop quiz on chapter 6, we haven't done chapter 6 or chapter 7, right? We haven't done it. Let's say that you don't know anything about chapter 6. And I give you this 10 question, a true and false test question, right? And now this is what they ask you is, if you go in there, because you don't know the material, you go in there and you randomly guess, right? You randomly guess your answer. What is the probability that you have 4 question correct? Okay, so problem A, this is P of 4, basically tell you is, if you go in there and you just go in true, false, true, false, true, false, true, false, right? You just go in there and just randomly guessing your answer. Now the question is, if you go in and randomly guess, what's the probability of you have exact 4 question correct? Okay, so that's our problem here. Our problem is we need to find the probability. So like I mentioned to you earlier, the 3 things that we need is this, ladies and gentlemen. How many total items do I have? What is my N? Which is, in this case, my N is equal to 10, which is the 10 question we have. The second thing we need is, what is the probability of you have a correct answer on question 1 or on each question, which is, everybody see that the probability here is 50%. Why 50%? Because a true and false question, you have only 2 choices. You have either a true or a false, right? Meaning, again, you have only 2 choices, which is, again, each time you guess, you have 50% of getting it right. On the other side of the spectrum, you have a 50% of getting it wrong, right? So again, the probability of success, the probability of you guess the question correct is 50%, which is 0.5. On your homework, if they talking about a multiple choice question, make sure how many choice you have. If a multiple choice question that have 4 questions and one of them is correct, which is 1 out of 4, the probability of you guess a multiple choice question of 4 choice correct is 0.25 or 25%. Okay, and if you have 5 choice, which is 1 out of 5, which is, that's the probability of you guessing a multiple choice question that have 5 choice right is 1 out of 5, which is 20%, 0.20. Okay, so again, the probability here is basically, in terms of this thing here, what's the probability of you have a correct answer? Okay, in this case, I have 50-50. Right, and the next thing we have is, again, the next thing we need to ask ourselves is, what is my X? How many successful tries are they asking me? Which is, in this case, the question I mentioned earlier is, they ask you, what is the probability, find the probability of making at least or make exactly 4 correct questions, right? So again, this thing here, you will see this word later on. I just want to write it this way, so later on when you see it, you know what I'm talking about. So looking at this thing here, we have the 3 items we needed, excuse me. We have the 3 items we needed, ladies and gentlemen, which is the X, the N, and the P. This is the 3 items we needed, which is now all we need to do is plug into your formula. So if you plug into your formula, everybody see that, again, this is what I have is, instead of writing X, instead of say P of X, I put in P of 4, which is my X is 4. So wherever I see an X, I put in a 4. Wherever I see my N, I put in a 10. And wherever I see my small p, I put in a 0.50 or 0.5. Okay, so again, this is what I have, which is, again, and once you have this thing here, ladies and gentlemen, this is all you need to do is using your magical calculator to calculate this item here, which is, can we find the 10C4? Well, 10C4, reminder, 10C4 were our combination problem, which is in your previous test in chapter 4. 10C4, pretty much you type in 10 mat, go over to P of B, and you're using this thing here, which is, everybody see that this is what I have. 10C4, I have 10 NCR4. this is what I have last time, which is everybody see that 10C4 is 210. And now I can put the 0.5. Everybody know that the caret sign, this caret sign underneath the clear button, this caret sign tell you to take this item and raise to that power, which is 0.5 raised to the 4 power. This is what I have. And again, everybody see that 10 minus 4 will give me, this is what I have, is I can say 1 minus 0.5 raised to, what is 10 minus 4? Well, 10 minus 4 will give me 6, which is, again, I can type in 1 minus 0.5 raised to the 6th power, which is, those are the 3 number I have, which is the NCR, which is the 10C4, I have 210. 0.5 raised to the 4 power, I have 0.0625. And 1 minus 0.5 raised to the 6th power, I have 0.01565, which is now all I need to do is take 210 multiply to 0.0625 multiply to 0.01565. And ladies and gentlemen, like I mentioned prior to this, like I mentioned before this thing here, when you do the problem, don't route in the middle of the progress, right? You want your process, you should use as many decimal as you can. You only route it at the final answer, which is the probability of you go in and guess this 10 2 and 4 question, the probability you have 4 of them correct is 0.2051, which is, again, this is what we have in terms of this item here. And again, this is all what I did earlier, just that now this is the number come in, which is, again, as you can see, have exactly 4 questions correct on this test is roughly 21%, right? Meaning if you don't know anything and you just guess on this test, you will have 21% of get 4 correct questions. That's what this answer tell you is, if you go in there blindly, just put true, false, true, false, false, true, true, false, false, true, false. If you go in there just blindly, just put that number, you will have 21% of have 4 out of the 10 question correct. Okay, exactly 4 out of 10 question correct.
Mr. Train.
Yes.
I have a question regarding the answer. You got 2.051. I got 2 point. So the 2 is before the point, and then
you probably have something wrong in terms of the number. Type again. You should have 210 multiplied to 0.0625 multiplied to 0.015625. So one of this thing here, you probably miss a 0.
Yeah, I missed the 0 in the second 0.15.
Yeah, so if the 2 come, remember we looking for probability, ladies and gentlemen. Remember, we're looking for probability. So if your probability is bigger than 1, we did something wrong. Our problem is something wrong. Remember, every time we find probability, it's have to be between 0 and 1, right? So again, maybe like I said, you're probably missing the decimal somewhere, or in this case, you're missing the 0 in front of the 1. That's why you have bigger than 1. Okay. So first of all, question on where my number came from and how to use your calculator to calculate this thing here, or using this formula to calculate. Any question on where my, again, the reason I have 6 here is because of the, again, 0.5 is because 1 minus 0.5 will give me the other 0.5, and 10 minus 4 will give me 6. That's where my 6 here and my 0.5 is here, okay? So again, hopefully every other number you guys see where my number came from. And again, you can plug like this to your calculator. You can plug, just open parenthesis, 10C4, close it, multiply to open parenthesis, 0.5 raised to the 4 power, close the parenthesis, open. If you type it like that on your calculator, they can calculate it for you, okay? But anyway, let's take a look at B. So what does that mean, fewer than 3? Well, fewer than 3, this is what they tell you is you go in here and take this test, and they ask you what is the probability of you answer this test and you have fewer than 3 correct questions. fewer than 3 question correct. Meaning, do you agree that fewer than 3 meaning the 2 is fewer than 3, the 1 is fewer than 3, and the 0 is fewer than 3? Meaning, again, fewer than 3, we cannot use 3, right? 3 is not smaller than 3. Meaning, in this case, everybody see that fewer than 3 meaning they can be 2 question correct, or 1 question correct, or 0 question correct, which is, this is the probability of or is just, instead of say, find me the probability of 2 or 1 or 0, they just say fewer than 3, which is, again, in terms of this thing here, you have to ask yourself, what fit this description fewer than 3? Meaning now, in terms of this thing here, you see that we have 3 different x, right? Meaning, again, my x can be 2, my x can be 1, and my x can be 0. So basically, we have to do 3 different problems, or we have to do 3 different items here, which is, again, all I do is my x, the 3 items we needed, the n, the p, and the x, right? Which is, again, in terms of this thing here, I have 10c2 multiplied to 0.5 raised to the 2nd power, multiplied to 1 minus 0.5 raised to the 10 minus 2, which is, in this case, again, 10c2 will give me 45, 0.5 raised to the 2nd power will give me 0.25, and 0.5 raised to the 8th power, why 8? Because 10 minus 2, which is, again, if you punch in your calculator, this is what you should have, is 45 times 0.25 times 0.00390625. And if you multiply them all out, this is the first item we have is, if we go in there and randomly select your question or your answer, not question, you randomly select your answer to answer your question, the probability of you have 2 correct answer is 0.0439, okay? And then we have to do the 1 because, again, like I mentioned, fewer than 3, meaning the 1, the 2, and the 0. And if you plug it in, this is what we have, which is, again, if you plug it in, 10c1, which is you have 10 choice. And again, 0.5 raised to the 1 power is 0.5. 0.5 raised to the 9 power is 0.0019. So on. Take the 3 number, multiply, you get this. And lastly, we have to do the 0, which is, again, 10c0, you have 1 choice. 0.5 to the 0 power is equal to 1, which is, this is what you have. And if you multiply this thing, this is the 3 item we have here, which is, this is x equal to 2, x equal to 1, and x equal to 0, which, how do I find this probability? All I need to do is take the 3 items and add them together. And again, I know some of you guys say, oh, why don't we route it? Like I mentioned, we don't route your answer until the last final answer, until the last steps. That's your final answer. That's what you want to route. Because if you keep on route, if you keep on making estimate, sometimes the answer will be off by a digit or so. Okay, so we don't want to route until the final answer. Okay, we want to keep at least 6 decimal as possible. And then again, the final answer, because most of your Connect math, they ask you 4 decimal place. I think is the most that they ask you is 4 decimal place. So again, if they ask you for 6, then you want to keep 8 decimal place until the last answer. Okay, but again, this is the idea here is the difference between this problem, part B, versus part A is part A, they just ask you the exact 4 questions. Part B, they ask you fewer than 3. Well, fewer than 3, what fit the description of fewer than 3? Well, fewer than 3 will be the 2 question correct, the 1 question correct, or the none of the question correct, right? Which is, in this case, as you can see, we have to do individual for the 2, individual for the 1, individual for 0, and then add them up. And we see that the probability of me go in here and guess, randomly guess my answer, I will have 0.0547% of have a correct question, fewer than 3 correct question. Okay, so again, is this a unusual event? Is not. Okay, remember the cutoff for unusual is less than 0.5. This is 0.5, less than 0.05. This is 0.054. So again, there's a number back here that's bigger than 0.05. Okay, so again, this is more than 5%, is 5.47%. So this is still usual. It's not unusual. Okay, but again, let's question, first of all, question of how I have the number, where I get the number from, and why do I have to do all three? All right, if you don't have question, let's go back to this, which is again, the answer for part B. We know that the answer is 0.0547, which is again, on a different slide. I'm running out of room. So let's take a look at C. If you don't have question for B, C, they ask you again to pass the test. To pass the test, the student need to answer 7 or more questions correct. Would this be unusual event? So again, what does mean? Again, forget about the unusual first, which is again, to answer this thing here, to answer the unusual or not, we have to know, is my probability bigger than 0.05, right? To do that, as you can see, part C, this is what they ask you is, in order for you to pass this thing here, you have to answer 7 or more questions correct to get 70%, right? If you have 7 questions correct, 70% on the test. 8 questions, 80%, 90%, or 100%. But again, this is meaning, again, do you agree that this basically tell you that you have to answer 7 questions correct, or 8 questions correct, or 9 questions correct, or 10 questions correct? Meaning again, in terms of this thing here, to do this problem, we need to find the x, right? We need to find the x of x. X can be equal to 7, X can be equal to 8, X can be equal to 9, and X can be equal to 10. Meaning, what do I need to do? As I mentioned to you guys, later on you will see that this 3 item is the 3 things that you need the most in 5.2 is you need the N, you need the P, and you need the X. You need the probability, you need the total, and you need the individual that you want it to be correct. So in terms of this thing here, if I plug in my 7, P of 7, basically again, I have 10 C7 multiplied to 0.5 raised to the 7 power multiplied to 1 minus 0.5 raised to the 10 minus 7, which is basically I plug into this formula. And if you do that, this is what you should get out. Similarly, you have to do that for the 8. Similarly, you have to do it for a 9. And lastly, you have to do it for the 10 because again, this is the probability of you have exactly 7 questions correct. This is the probability you have exactly 8 questions correct. This is the probability you have exactly 9. And this is the probability you have exactly 10. And once you have this thing here, what we need to do is, because we're using the addition rule, because this or that, basically we take all this thing here and add them together. And once you add them together, this should be your answer, which is 0.1719. Okay. So again, as you can see, yes, it's a little bit tedious, right? It's tedious in terms that you have to punch is a lot of number crunching, right? Punch all this number in your calculator, but the calculation should not be hard because again, all you do is you plug in your formula and then your calculator do the rest, right? So again, first of all, question in terms of why I have to do for all 4 of them, and again, how I have this number, where I have this number come from. Any question here? Now, if you don't have question, go back to the unusual category. Remember, the cutoff is, in order to be unusual, your probability have to be less than 0.05. Is this number 0.1719? Is this number less than 0.05? Which is hopefully you say no, right? This thing here is not unusual, okay? It's not unusual, meaning it's usual, right? Not unusual. It would be usual because the probability is more than 0.05. So again, on Connect Math, I think part C, you have to click down, is it unusual or not unusual, or usual or unusual. So again, this thing here is not unusual, therefore is usual. right? So again, in the sense of this thing here, if your probability is less than 0.5, meaning if your probability is 0.03, it's unusual. If your probability is 0.049997, is unusual. It's less than 0.05. Okay. Only, they won't give you something that exactly on 0.05. Your probability will be something more, meaning 0.052. That is still usual. If it's more than 0.05, is usual. If it's less than 0.05, it will be unusual. So it will be very, 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 very rare that you calculate and your answer come out to be exactly 0.05. It's rare. But if it's happened, 0.05 is still usual. Okay, it won't happen, but if it's happened, it is still usual. It's only when it's less than 0.05, then it's unusual. Okay, but again, question with this thing here, question on how I find part C, or why do I have to do all four of them, and how to answer if it's usual or unusual. All right. If you don't have question, like I mentioned to you guys, right? There are three methods to solve this problem. So the first method is we using our formula, we construct our formula, and we put in our formula, and then we just